Keyword search fails at matching resumes to jobs. A candidate writes build distributed systems in Go. The job says backend engineer with microservices experience. 0 shared keywords. Perfect semantic match. In the next 5 minutes, we'll dissect one realistic reference architecture that fixes this. Azure OpenAI for embeddings, Azure AI Search for vector retrieval plus semantic reranking, and Python glue tying it together. We'll trace the ingestion pipeline, the query flow, the two-stage retrieval that makes results actually good, the failure modes, and the trade-offs and architect ways. Let's get into the diagram. Here's the whole system. A Python ingestion service reads resumes from blob storage, calls Azure OpenAI's text embedding 3 large model to turn each one into a vector, and writes those vectors into an Azure AI Search index. On the query side, an API, say Azure Functions or Container Apps, takes a job description, embeds it the same way, and queries AI Search. Key Vault holds the keys so nothing is hard-coded. Notice embeddings and search are separate services. One generates vectors, the other stores and ranks them. That separation is the heart of the design. Ingestion runs once per resume, not per query. First, extract and clean text, strip PDF formatting noise. Second, chunk it. Resumes are short enough that one document per resume often works. But if you index per section, you get finer-grained matches at the cost of more vectors. Third, call the embedding model. Text embedding 3 large returns 3072 dimensions. Fourth, upload the document with its vector field to AI Search. Batch your embedding calls. Sending 50 resumes per request is far cheaper and faster than 50 round trips. Re-embed only when a resume changes. Store a content hash to skip unchanged ones. This is where the quality comes from. Stage 1 is fast. Approximate vector search using HNSW hierarchical navigable small world graphs, which pulls back, say, the top 50 candidates by cosine similarity in milliseconds. But pure vector similarity is fuzzy. The ranking near the top is noisy. So stage 1 casts a wide net. Stage 2 is the semantic reranker. AI Search runs a cross-encoder model from Microsoft over those 50 results and rescores them against the query, returning a precise top 10. Better yet, use hybrid search, combine vector similarity with BM25 keyword scoring, so exact terms like a specific certification still count. Here's the query side in Python. You embed the job description, then pass that vector to AI Search alongside the original text. Setting query type to semantic turns on the reranker, and the search text drives both BM25 and the cross-encoder. The vectorized query carries your 50 nearest neighbors. The response comes back already ordered by reranker score. Note this is illustrative, the SDK surface changes, so check the current Azure docs for exact parameter names and the latest API version. An architect has to justify the extra re-ranking step, because it adds cost and latency. Pure vector search is cheap and fast, but its top results are often only roughly right. It can't tell that 15 years of leadership matters more than a one-line keyword overlap. The reranker fixes ordering precision, which is exactly what hiring decisions need. The trade-off: re-ranking is a build feature with its own quota, and it adds tens of milliseconds. For a matcher where the top 5 results are what humans actually read, that precision is usually worth it. That's a rule of thumb, not a law. Where does this break? First, dimension and model drift. If you re-embed with a different model than the index was built on, similarity scores become garbage. Pin the embedding model and version. Second, throttling. Azure OpenAI enforces tokens per minute limits, so batch and add retry with backoff during bulk ingestion. Third, stale data, resumes change, so wire a content hash and reindex on update. Fourth, fairness and bias. Embeddings can encode demographic signals, so treat this as a ranking aid for humans, never an automated reject. And cap input length. Both the embedding model and reranker truncate, so very long resumes lose their tails. To recap, store resumes in blob, embed once with Azure OpenAI, index the vectors in Azure AI Search, and at query time run hybrid vector plus keyword retrieval followed by semantic re-ranking to get a precise shortlist. The separation between an embedding service and a retrieval and ranking service is the design's backbone. Your one concrete next step: stand up a small AI search index, enable a semantic configuration, and compare pure vector results against re-ranked results on 10 real job descriptions. Measure the difference before you commit to the cost. And because pricing, quotas, and SDK shapes change, confirm the current Azure docs before you size anything. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.